Welcome course. This is the review for the midterm. I'm going to probably do the midterm review in 3 separate videos. One covering section 1 and 2, a second video covering sections 3 and 4, and probably a final video covering the remaining section. So let's just go over the test and have a look at it. Your test will only be 120 minutes instead of the 150 listed here on this exam, so that will be good. Again, this is kind of like your grade sheet and everything. So I did provide in the previous midterm, again, this one will be slightly different, but we did talk about sorts and kind of the run times of them previously, whereas we haven't gone into those topics now. So some of this is not 100% relevant, but it does give you kind of the outline of what to kind of expect and some of the questions and similarities of what you might find on your midterm. So I provided a few of these common run times in our current midterm, and our final we won't have this page, but here I did provide it. So let's go over sections 1 and 2. Section 1 is a simple matching. Usually I typically either do a matching or a true and false section, so this one just happens to be matching. And what we'll do is we'll go through, and what we're going to do is pick the best answer for each one. There's a few times that maybe we don't know the correct answer right off the bat because a few of them fit it, but eventually we'll come to places where we do have the best answer, and eventually by status of elimination we come up with the best one for each one. So for a stack, if we look over here on the right hand side, basically one of the operations of a stack is a pop, and so pop it off the top is kind of where stack will go there. So if we do a little line, stack would be pointed up to G. Q, basically we talked about Q's, and there was that bread line. So if we look over here on the right, basically the lines at Fry's Electronic, when you check out, the first person that gets there gets the first cashier, and then so first in, first out, and so a Q matches that excellently. So let's draw a little line there. So Q points out to the line at Fry's. Array list, basically from this, I see a few things that go through it. Basically, if you go from the length of beginning and end, you could get array list. Internals of one way, you could kind of think of array list. Random access, array list provides random access. So far, that one probably is matching up with array list, but let's skip that and go to some of the others because I think there's some easier ones in this list. Linked list, this one doesn't say doubly or singly linked, but because number 6 does say doubly linked, we can assume this is a singly linked linked list. And maybe one way to think of that is one way here. So linked list will point out to one way. Recursion, if we look through everything here, there's this one that says I keep repeating myself, which is kind of the definition of recursion. You keep calling the same function. So recursion is number H, or letter H. I keep repeating myself. Now doubly linked list, we can go both forwards and backward. So the structure that goes forward and backwards, doubly linked list fits that nicely. And I think that's, from the remaining ones left, that is the best answer for that. Iterator, as you recall, generics, when they were introduced, iterators kind of came along with that, and the for each operator kind of came along with that as well. So to use the for each, you need to have an iterator essentially. So for each and iterator are the best matching there. So iterator to for each. A deck, remember, is a double-ended queue. So with that double-ended queue, kind of both sides are available would be the best answer there, because double-ended kind of implies both ends are available. O to the n is the time basically that it takes to go from the beginning of a list to the end, or go through all the data elements once. So I think the best thing there is the length of times to go from the beginning to the end, kind of stepping through it. So O to the n, the best answer there is number A. Node, we've used that a lot of times in pretty much all the data structures that we've covered. So it's one of the internals of that structure, so the best answer for a node is that internals answer. So if we go through here, everything A, B, C, D, E, F, G, H, and I all covered, which means random access is array list. Since array list is based off of the array, we do get random access at a cost of O to the 1. So the best answer there for array list is random access. So here's our lines and everything for all the answers in this matching section. Now section 2, this was a little question. So you have an array filled with randomly filled with zeros and ones. We don't know the order of that 0 or 1s, nor does it matter. But your job is to order the array so that all the zeros are first and all the ones are second. So we have this is 1, 0, blah, blah, blah. And what we want to do is get all the zeros at the front and all the ones at the back. So explain your approach that matches the various O to the big O runtimes. So one way to do this problem is, if you kind of recognize this, is since all the zeros are front and all the ones in the back, it's almost like a sorting problem, where the values that are lower are first and the values that are greater are at the end. So a simple solution to this problem would be using a sort such as bubble sort, which would then give us big O to the n squared. So basically, all you would have to do is explain, sort the array with the bubble sort algorithm. Bubble sort by definition is O to the n squared, which thus matches our runtime that we want to obtain. So essentially, you write bubble sort, you say you're going to use that, and the reason why is that bubble sort runs in O to n squared. Next, since we've already established the fact that this is a sorting algorithm, n log n is another sorting algorithm that we could essentially use. So if we go back up here, we see that two available options are the merge sort or quick sort. So we could just simply go down to here and say, by sorting the array with the merge sort or quick sort algorithm, we will get an n log n runtime, as that is the runtime from those algorithms. So that would be our answer for O n log n. Finally, there's several ways to do O to the n. Most of everything else requires some way of keeping track of this, but a simple way to do this is to, most people, what they did is simply take all the zeros and put them on one array list, and put all the ones in a second array list, and then append the array list together. Another way is to create a linked list, and every time you get a 1, append that to the tail. Every time you get a 0, append it to the head. So there's a few different ways. Probably the linked list is probably a little bit simpler to implement. And so those are all different approaches where you go through the algorithm once, where you pop off. Kind of a second way is that you count all the zeros and you count all the ones, and then you go ahead and create the new array by doing how many zeros and then how many ones. All those require kind of a separate data structure, and really doesn't do it in the actual place of the actual algorithm. So one way to do this in place and for the extra credit here is we have all we do is we need 2 pointers. One that starts at the beginning of the array and one that starts at the end of the array. The pointer at the beginning of the array looks for ones, and the pointer at the end of the array looks for zeros. So we go through, for this input example, we start at the beginning and it looks for ones. We found 1 right away. Our 1 at the end starts and finds a 0. So our 2 pointers are now, and since they both found what they're looking for, we swap those 2. So 0 becomes 1 and 1 becomes 0. So we swap them. Now this changes to 1 here, and this changes to 0 here. Next, we keep on going with that 1 at the beginning. So we were here, it goes to here, and then here. That's a 1. And then we were here at the back, so we go to here. So now our 2 spots are there. We swap them, and that would be our next value. And we continue to run the algorithm until our 2 pointers basically cross each other. Once they've crossed, we know that everything has been done, and the array should be in the proper order of all the zeros at the beginning and all ones at the end. So that is the way that I would look at doing the extra credit, and that does it in place as we go through the algorithm at most O to the n times. So there's section 1 and 2. I will then cover 3 and 4 in separate videos. So thank you, and I'll be posting up the rest shortly.